Okay, good evening to everyone po. We will continue our discussion on Google Sheet. So we are now at data analysis using statistical tools. So in this session, we will be discussing descriptive analysis uh, and also statistical inferential statistics. So in Google Sheets, we have this statistical tool, which is an advanced analysis tool pack, no? Because if we do not use this statistical tool, we will be using manually the formulas, no, for our mean, median modes, or for our inferential statistics like our correlation matrix, correlation analysis, and our inferential statistics such as the t-tests and the ANOVA and etc. Okay, so first, how do we access our Excel minor analysis tool pack? By the way, this Excel minor analysis tool pack is the counterpart of the advanced analytic tool pack in Microsoft Excel. So let me just show you the Microsoft Excel. No, so in Microsoft Excel, there is also an advanced analysis tool pack, which is here in the data analysis, wherein you can perform different statistical analysis. Okay, like this one. Okay, just wait for it to load. So since we are gonna use Google Sheet, so we can also do advanced data analysis using a counterpart in the analysis toolpack. So as you can see here in Microsoft Excel, you can perform ANOVA if you already have encountered in your careers or in your research journeys, the correlation, covariance, the descriptive statistics, and the like. Okay, the t-tests like this. Okay, so there is a counterpart in Google Sheet, which is called the XL Minor Analysis Tool Pack. So how can we access this one? First, we need to install this tool pack. So to install it, just open a new sheet, no? Just open a new sheet or your existing or our existing any Google Sheet, no? Then just go to extensions. Then in the add-ons menu, then it's either manage add-ons or get add-ons. So in here, we can get add-ons. Then in this search app here, just search XL Minor. This one, XL Minor Analysis Tool Pack. You just click it and you can see search results. So the one you will click is this link, the XL Minor Analysis Toolpack by Frontline Systems Incorporated. Okay, so you just click that. Then it says here, statistical analysis in Google Sheets with functions matching the analysis toolpack in desktop Excel, as I have shown you a while ago. So just click the install button here. Then it asks your permission, so just click the continue button. And then you need to authorize your account. So you sign in again. So if you have already signed in an account, so just click that one, or you want to use another account, just use this another account. So in my case, I will choose my existing account. Then it says here, Excel Minor Analysis Toolpack wants to access your Google account. So allow it, no? So never mind the settings. So just click the allow button here. Then wait for it to install. Okay, it will load. Then once it has been installed, okay, it says that Excel Miner Analysis Toolpack has been installed. So I will show you now where will you find it. Okay, just click done here or this X button here. So anything will do. Okay. Then just click the exit button here to exit the Google Workspace Marketplace. Okay, now the Excel Miner Analysis Toolpack has been installed. So how can we access the analysis toolpack? So we can access by going again to these extensions in your open Google Sheet or your spreadsheet that you want to analyze. Then there is now a new menu here, a sub-menu under extensions, which is the Excel Miner Analysis Toolpack. Then just click Start button here. Okay? Then wait for it to load. So it will be loaded on your right side of your screen. So this is the different statistical analysis and methods that we can utilize, no, in our data set. Okay, there is your ANOVA, single factor, then there is also your t-tests, and there is also your descriptive analysis. Okay, so uh, in our next slide, I will show you how to use this one specifically for a specific function or statistical analysis. No, so are there any questions for how to install this Excel Miner Analysis Toolpack? So if there are no more questions, so we will proceed, no, to our first data analysis. We have the descriptive analysis statistics. So I hope you are still familiar with the descriptive statistics. So let me again open our diabetes data set. So in here, I have for faster processing during our lecture, no, I have uh, gathered small row data from our row data. So what are the inclusions of our descriptive statistics? So we have, of course, the mean, the standard error, median, and the like. So I will just, ayan. So as the term, no, descriptive analytics, no, it describes our data. So by using measurements such as your measure of central tendency, your mean, median, mode, your measure of shape distribution, which is the skewness. Then we have also the kurtosis, the standard deviation, the standard error, the sample variance, and the confidence level. So how can we use, no, the our Excel Miner? So for example, we want to describe or we have descriptive statistics about our BMI, no, of our data set. So let me just unfilter this one, okay, to include all. Okay. Okay, so to do that, just open first your Excel Miner Toolpack. So I'll just check if, okay, it's only 61. So just open first the Excel Miner Toolpack. So click again the extension, the Excel Miner Analysis Toolpack, then click Start. Okay. Then you just copy, no? You just for lecture purposes, it's better that you have a separate sheet for your analysis. Okay, as I have said before. So just create a new sheet. So let me just BMI. Okay. Then you just copy your BMI column dataset, copy, and then paste it in another sheet. Then once you have copied in another sheet, so let me just format this one. Okay, so for descriptive statistics, how can we use it? So just go to the descriptive statistics right here. I hope you can see it. And then in here, the tool asking us to input range, then whether to check labels in first row, then never mind the summary statistics. Okay, so it should be remain checked. Okay, how can we utilize this one? So first, choose what choose the range, no, of what you would like to to analyze. So in our case, our BMI. So just select this one, then select all, and then the tool pack. In order, you can either type your range here, or there is as you have observed, there is no click button here. Okay, so what you do is you select first the data that you want to analyze, okay, according to what will be asked here. So in our case, input range, so we select first the input range, and then after selecting it, we just click the field text box here. Once we click the text box here, it will automatically fill the cell ranges, which is A1 to A61. Or you can type directly here, like that. So, but for me, it's easier, no? It's faster and easier if you just, because if you select, if you if you select first if you click the input range here without selecting the range first, so it's just like the button, no, the clicking of the text box is the buttons. Okay, so you should first select the cell that you want to analyze. Okay, then you click the input range so that the input range will be displayed here. And then, of course, we will group our data set by columns, as we have already said, as we have already know it. So column A, then we check these labels in first row if in our input range we included the labels in our first row. Okay, but don't put a check mark here uh, if you did not included it. But if you included your ranges, including your label here, then if you analyze this one, it will have an error. And then, so since we uh, included our labels, no, we should just check these labels in first row. Then you select where would you want to display the output or the descriptive statistics table. So in our case, so let me just click the C1 cell, because this is where we wanted to place our descriptive statistics. Then again, just click the output range so that it will be so that the cell C1 or the one you selected will be outputted here. Okay, and then never mind this one, the level confidence 95, summary statistics. Okay, then just click OK. Yan. So once you click that, you wait for it, not for the descriptive analysis will to load. Okay. So now we are ready to analyze. So there's your mean, your standard error, median, mode, standard deviation, until the confidence level. Okay. So we will discuss it by one on how to interpret it. Okay. So for our so I hope you're still familiar with your basic statistics or your descriptive statistics. So first, we have the measures of central tendency. So this describes that central data of our data set. Okay, it consists of the mean, the median, and the mode. So I hope you still remember your mean, median, and mode. So the mean is the sum of all the data points divided by the number of data points. So what is the other name for mean? If you are familiar, so the other name for the mean is our average. Okay, So in here, the mean can be skewed by extremely large or small data. So it's less reflective of the true central value of our data set. Okay? So in our data, the mean is 27.58. So meaning the BMI of our data set. Okay, okay. Sige, you can okay. Sure, Ma'am Oluwa. Okay.
Thank
So,
you, sir.
oo. Sige. So, meaning the mean of our data set is 27.586. So, the BMI of our data set has an average of 27.58. Then, for the median, it is the middle value of a data set when it's sorted in ascending or descending order. Okay? It is important to note, no, it is the middle value, no, it's based on counting. So if the data set has an even number of observations, the median is the average of the two middle numbers. So for example, you have 10 data sets, so the median is the average of the data set between 5 and 6. Okay? Then, so it is not skewed by large or small values. So it is not affected if you have of your data set has a outlier such as very large values or very small values. Then the mode, of course, is your most frequently occurring value in a data set. Okay? So for our mode, we have 26. So this is the most of our BMI in our data set has a BMI of 26. Okay? Then how about measures of shape of distribution? So we have this concept of skewness. So it is a measure of the asymmetry of the values in the data set. So di ba, our mean is in the middle. So we would like to know if our data is more on the right or more on the left side of the mean. Okay? So if the right tail is longer, it means that it is positive skewness or right skewed. If the tail is left tail is longer, it means we have negative skewness. And of course, if our data is symmetrical, zero skewness. So for our data, we have 2.46520. So how do we interpret this one? Since it is positive, so meaning we have a positive skewness. Then we can interpret it as either highly, moderate, or symmetric. If it's highly skewed, we have either less than -1 or greater than 1. Moderately skewed, we have less than 1 to less than 5 to +1. Or if it's symmetric, less than 0.5 to 0.5. Okay, in our highly skewed positive data set since it is greater than +1. Okay? Tails of a distribution, no? Comparing to a normal distribution. It identifies whether the tail of a given distribution contains extreme values or extreme outliers. So, how to interpret? We have either positive kurtosis, negative kurtosis, or zero kurtosis. So for our data, we have 9.77. So meaning we have a positive kurtosis since it is greater than 3. Okay? So meaning in our data set, no, there are values that are high from our mean, which is the 27.58. Okay, so let me check, no. So it's true because we have a value of 58. So 58 is very high from our mean, which is 27.58. That's why it's a highly skewed. That's why the kurtosis is 9.77. Okay, so that's the meaning of kurtosis, we have a value that is very high, that is an outlier, no, from the mean. Okay, so that's for the kurtosis. Then for the standard deviation, it is a measure of amount of variation or dispersion in a set of values. So it is usually the square root of the variance. Okay, so in here, we have the standard deviation of 7.41. So if you are reading, no, reading research papers, we most specifically if there are interpretations in the weighted mean like that, di ba? So there are values like 27.58 plus minus 7.41. So it is the allowable distribution or dispersion of data. Okay, so if you have a lower standard deviation deviation, it means that the values tend to be close to the mean. Since, for example, you have a standard deviation of 27.58 plus minus 2.4, so it's closer to the mean because you only have about 25 to 29. So 25 BMI and 29 BMI is closer to 27. Unlike this, if you have standard deviation of 7.41, which is roughly about 20 to 34, okay? Meaning the dispersion of your BMI is between 21 to 30. Okay? So in our data set, the standard deviation is approximately 7.41. So this indicates that most BMIs in our data set are within about 7.41 units of the BMI. So most of our patients have a BMI between about 20.2 and 35. So this is the concentration of our BMI of our patients. So most of them have BMI between 20 and 35. Okay? Then standard error, this is also a measure of the precision of your estimate. So a smaller standard error indicates the sample mean is a more accurate reflection of the actual population mean. A larger standard error means it is less likely to be precise reflection of the standard mean. So, of course, so what we want in our analysis is we have a lesser standard error because it is more reflective in the sample is a representative of our population. So if we have only a standard error of a smaller standard error, it means that our sample is most probably an accurate, more accurate reflection of our actual population mean. So in our case, the standard error in the data is 1.38 since it is relatively small. Okay, this indicates that if we were to take multiple samples from the population, our average, no, each time we calculate our average would not vary greatly from the overall population mean, which is 27.6. So meaning, if you select random data in your data set and compute their BMI, their average BMI would always be closer to the population mean, no? The mean of your population. Then sample variance, the average of the squared differences from the mean. A measure of how far each value in the data set is from the mean. So, diba, our standard deviation is the square root of the variance, or this one. So, square root of the sample variance is your standard deviation. Then what about confidence level? So, if we say confidence level, it is the estimated range of values calculated from a given set of data or from a statistical analysis, which is likely to contain the value of a known population parameter. So the range is defined by the confidence level, which is usually expressed as a percentage. For example, 95%. So how do we interpret? Since we used confidence level of 95%, which has a value of 2.82. So how do we interpret that one? So meaning the 95% confidence level in the BMI data implies that if we were to take 100 different samples from our population and we compute a 95% confidence interval for each sample that we obtain from the population, then approximately 95, which is of the 100 confidence interval or the 95%, will contain our mean. Okay, so that means we can be sure that 95% we are 95% confident, no, that the population mean will fall between the 25 and 30.4. So where do we get the 25 and 30.4 BMI? So this is the formula. So for the lower limit, we will subtract the confidence level 95% of the mean, which is 2.82 based on the standard table, no. We have the our mean is 20. What's our mean? Our mean is 27.58. So just for your information, so this is how we compute for the confidence level. So 27.6 minus this one 2.82, where did we get that? Here. Okay? 2.82. So uh, we obtain for the lower limit 27.6, which is the mean, minus the 2.82, which is the confidence level 95% we obtain from the descriptive statistics. It would be 25. Then for the upper limit, we need to add, because it's upper limit, 27.6 for our mean plus the 2.82, we obtain 30.4. So our range is 25 to 30.4. So the interpretation here is that, okay, we can 95% confident that the population mean will fall between 25 and 30.4, which is true naman, di ba? Our mean is 27.58. Okay, so that's the interpretation. Okay, so this is all for the descriptive analytics. So we can use the XLM minor analysis toolpack descriptive statistics model here. Okay, so if we do not have any questions, we will proceed with our next slides. So as I have said earlier, skewness indicates whether the data is concentrated on one side, because as much as possible, we want our data to be symmetric or bell-shaped curve. Okay? Because we want it to be representative of the mean. Okay? So this is the appearance of the positive skew. The right tail is longer, okay? So which means that most of the data points, or most of, in our case, the BMI, most of our BMI falls in the right side of our histogram. Okay, this is our histogram. So you can visualize the skewness through a histogram. Zero skewness, as you can see, it's symmetric. So it's equally distributed between the left and the right side of the mean. And if it's negative skew, it's more on the left tail. So this is the left tail. Okay? So yun. Then one more thing, if you do not have, so doctor, how can we know if there is a positive skew without visualizing the data? So you can tell whether it's positive skew, zero skew, or negative skew by looking at your mean and median. Okay, so if your mean is greater than your median, it is positive skew. Okay, if your mean is equal to your median, it's symmetric or zero skew. If your mean and your median, if your mean is lesser than your median, in our case 4.9 and 5.0, it's negative skewed. Okay, so we clear. So positive skew, mean is greater than the median. Zero skew, mean is equal to median. And the negative skew is mean less than median. Okay. Now, let's go now to our correlation analysis. So, what is a correlation analysis? So, it is a statistical technique used to understand the relationship between two or more variables. So, if you have variables in your data set and you want to know what is the relationship, okay, we will use correlation analysis. Okay, what do we mean? So we get the correlation coefficient. Okay, what is the correlation coefficient? Correlation coefficient is a value between -1 and 1 that represents the strength and direction of the linear relationship between the variables. If we say strength, it's either strong, moderate, weak, mildly weak, okay? And if it's direction, it's either positive, negative, or no linear relationship. Okay, so how do we interpret it? If your correlation coefficient is close to 1, positive 1, it indicates first a positive relationship. What do we mean by a positive relationship? It means that when one variable increases, the other also increases. For example, if you want to compare age and the risk of having diabetes, meaning if the age and diabetes has a positive correlation coefficient, it means that as the age increases, your risk of having diabetes also increases. Okay. If the correlation coefficient is close to -1, it also indicates a strong negative relationship. So it's inversely proportional relationship, meaning as one variable increases, the other decreases. So for example, the history of smoking and the risks of diabetes. Okay, so if the relationship has negative correlation coefficient, it means that if you are smoke, if the more you smoke, okay, the lesser of you of having diabetes. So if that's the case, okay, then if correlation coefficient is close to 0 or is equal to 0, it indicates no linear relationship between variables. So there is no relationship. Okay? How about strength? How can we say if it is strong, moderate, mild, or weak? It depends on your use case. For example, if you are studying the factors on how or the factors, what factors that can predict the risk of having, let's say, heart failure, so you should search for existing literature, no, that uses also correlation matrix and what levels does it use, no? Kasi because each use case has its own different strength. So like for example, 0.8 to 0 to 1 might be strong uh, positive relationship for a certain research or study, but it's but other study would be higher, like for example 0.9 to 1. So best practice here is to search for a related literature of a similar study of yours, no, in order for you to interpret your results later on. Okay, so this is an important part. So in the correlation analysis, we only determine if there is a relationship between two or more variables and what is the relationship and how strong is the relationship. Okay? So let's go now to the how can we do it in our analysis toolpack. So again, if your analysis toolpack is closed, okay, for example, this one, so just go to extensions, then in the Excel minor analysis toolpack sub menu, then click start, wait for it to load in your right side of your Google Sheet screen. Then the best practice, as I have said, always, okay, always do analysis in separate sheet from your raw data. Okay, so for example, we want to analyze the correlation, the relationship, no, between all of our variables. Okay, that determines whether the patient will develop diabetes, 0 or not. Okay, so what you will do, so you just copy all these values. So don't copy the empty ones. Then go to your new Google Sheet where you will do your analysis. Then paste it. Okay, and then in here in the Excel minor analysis tool pack, you just click the correlation, and then again, okay, before you click the box in the input range, you select first your ranges, no? What ranges would you like to analyze? So in our case, all of these ranges, and then just click the input range button, and then the range will be copied here, okay? Then, of course, group by, we are grouping the variables in columns, okay? Then, labels in first row, you check it if you included the headers, the column headers in your input range. So, in our case, we included it. So, therefore, we check the labels in first row, okay? Then, we uh, select where we will want to place our correlation analysis table or the correlation matrix. So in our case, let's put it in our X1 cell, then click this output range, and then click OK. Then wait for it to analyze your data. Okay, so this one, it is analyzing. Okay, so this one. Okay, so as you can see, there are num. So if you see num, so it means that you cannot compare their values because maybe it is divisible by 0, or maybe you should do cleaning of data. Okay, so in here, how do we interpret this one? So as you can see, this is our, so this is an example of a correlation matrix table, okay? So our correlation matrix, let me just make it smaller. Okay, here it is. So as you can see, you have your variables here, and you have also your variables up at the top until this one. So in Google Sheet, no, Google Sheet will give you a semi-triangle, a half triangle correlation matrix. But in other analysis tools like your Python, okay, uh, your correlation matrix can be set up to include the whole table also. It's just a mirror of your it's just a mirror of your half triangle. Okay, so how can you interpret this one? Okay, so as you noticed, you have your variable here and your variable here, and there is a correlation coefficient here. So meaning the correlation between your variable diabetes and itself is always 1. That's why it's 1. Okay, so for example, why is 1 there? Because the correlation of high BP, so what's the intersecting variables of this value? You have your high BP and your high BP. That's why it's 1, and so on and so forth. So of course, the relationship of the variable in itself is always 100% or 1. Okay, then how can you interpret this value? 0.4355163866. Okay. So this means that the correlation coefficient of between what's the intersecting variables of this value, it's the high BP and the diabetes binary. So meaning the correlation coefficient of high BP and the variable diabetes binary is 0.4355163866. Then how can you interpret? First, you interpret what is the direction of the relationship. As we have said, is it either positive, negative, or no correlation? If it's positive, it's closer to 1 and it's not 0. If it's negative, it's closer to -1 or not 0. So 0.436 is basically, it's a positive value which is closer to 1 and it is not 0. So therefore, it's a positive correlation coefficient. But how how strong is it? So as I have said, it depends on your use case. So it's 0.43. So it's closer to 0. So in reality, it's closer to 0 because 0.5 is our middle between 0 and 1. So 0.4 is closer to 0, meaning it's either weak, okay, moderate or weak relationship, but it depends on your use case. How about high cholesterol? So it's weak also. So it's closer now to 0, weak. So in certain studies, you can say that if it's already weak, it not all research, no, but depending on your use case, some researchers would say to you that a value that is closer to 0 is already considered as no correlation at all. Okay? So this one. So how about smoker and diabetes binary? So our value is negative 0.1747141396. So it's a negative. So meaning it has a negative relationship. Now, how can you interpret this in layman's term? So for example, high BP and diabetes binary. So it means that always start interpreting with your factor or your independent variable, which is high BP. It means that, so in our study, there is a weak or moderate positive correlation between high BP and diabetes mellitus, which means that as your blood pressure goes high, the chance or the risk of you have developing diabetes also goes up. Okay, so that's the interpretation. Okay, so I hope we are clear. For example, high cholesterol and diabetes binary, it has a positive correlation coefficient. It means that the higher your cholesterol, the higher the chance of you having diabetes. But it's only a weak. So it's only weak. Okay? It's only weak relationship. Okay? So the more important thing here is that you will see uh, what among the variables, okay? So in your research, for example, in your objectives, you can state there that uh, what are the factors that determines, okay, that predicts, no, that predicts of having that predicts patients of having diabetes, okay, of developing diabetes. Okay, so what we will do, so this is also important. So our correlation analysis is also very important in our machine learning tasks. Why? We can use it, we can use our correlation coefficients or our correlation analysis in doing what we call feature selection. Okay, so what is feature selection? So in machine learning, if you say feature selection, you would only choose, as I have said in our previous lecture, you should only choose what are the variables that you need, no, to train your machine. Okay, why is that so? Because, okay, if you include all of this one, it will affect first the machine learning performance. It can affect your accuracy. It can also affect the precision, or in overall, it can affect the uh, machine learning performance or the evaluation matrix of your machine learning, because you feed your machine with unnecessary variables that is not like us, di ba? When we are learning, okay, when we are learning, we do not memorize all naman eh, di ba? So we do not memorize all. Because if you memorize all, no, you will be confused. So it's the same also with our machine. And it will, if we are confused, okay, uh, our chance of having correct answers in our exam, for example, is getting smaller. Okay, so this is the same concept in our machine learning. Okay, we only choose, so feature selection, we only choose what variables are highly or maybe moderately to highly correlated with our target variable. So in our case, if we want to build a machine learning that predicts whether the patient has diabetes or not, we will only select those variables or profiles of our patients that we need to collect from them that has high correlation to diabetes. Okay? So in our case, how can we do that? So we will, so how can we do that? So we will filter, okay? We will sort our correlation matrix, okay? From highest to lowest. Okay, so what we will do? Okay, so since our target variable is always, our dependent variable should always be in the x-axis, and our independent variable is in our y-axis. So we select our this one, the diabetes binary, and then we copy all this one, okay, and then we paste it in another cell. So we paste this one, okay, and then we clean the data. Okay, so we remove now the not needed. We have the cholesterol check and the diabetes binary. So we delete this one. So delete cells, then shift cell up. So don't use the delete row because it will delete your entire row 27. So if this is the case, you just select this one, right click your mouse, delete cells, and you should shift left, shift up, so that the high BP will go up. And then what else? We will delete also the column check. Okay, and then again delete cells, delete cells, and shift up. Okay, so now we can now filter our data. Let just me So we sort our data, I should say. So we can now sort our data from the highest to lowest. Okay. So just how can we sort this one? So just click the label and the details, and then data. Then we use the sort range and advanced sort range. Then we sort by, what's our column? By Y. Okay. Then we want it from descending order, so we choose the Z to A. And then click sort. Okay, so now, so we now have the data for our correlation analysis. Okay, so you can now interpret your result. And then, is this, you can now interpret the result. So we can see here that, how can we interpret now? So among the factors that determines whether the patient will develop diabetes or not, the highest the highest factor is the general health or the health condition of the patient. Okay, so in our previous lecture, that's why you need to know what is the meaning of general health, the difficulty of walking, like that one, so that in your analysis, you will know how to interpret. Okay, so in general health, 0 to 1. So as you go up, it's more excellent. Okay, let me check if that's the case. Wait. Maybe I'm wrong. Wait lang. Let me just check if I am correct or I am wrong. So where is our data set again? Uh, okay, here. What's this one? The general health. Okay. According to our general health data, let me just show you. So in our general health, okay, it means that 1 is excellent, 2 is very good, 3 is good, 4 fair, 5 poor. So from the description, we can interpret that as the general health goes up, the patient has a poorer general health. Okay, so that's the premise. So what is the result of our correlation analysis? It's 0.5379293618. So this means that, how could we interpret again? General health has a positive relationship with diabetes binary variable. Okay? Then we can include how strong. So it's 0.53. So maybe, as I have said, you should search, no, or specific values if it's either moderately or strong. But since it is closer to 0, it's either moderate or strongly correlated. Okay, so to summarize, no, general health has a moderate to strong positive correlation with diabetes binary, which means that as the patient's general health becomes poorer, the risk of the patient having diabetes also increases. So in reality, di ba, this is correct because, di ba, there are certain factors, no, di ba? So our data seems to be reflective of the reality, di ba? Because if you have a poor health, your chance of developing diabetes is very high. Okay? Then same is true with the difficulty of walking. So what's the difficulty of walking? So the difficulty of walking states that 0 if the patient has no difficulty of walking, and yes if it has difficulty of walking. So how can we interpret that one? So difficulty of walking has a weak to moderate positive relationship or correlation. Correlation is also called relationship. So difficulty of walking has a positive as either a moderate has a weak to moderate positive correlation with diabetes mellitus, meaning uh uh the if the meaning as the patient having difficulty of walking, maybe he has, no, he has a diabetes, di ba? Since what can we learn from this one, di ba? Diabetes, di ba, one of the complications of diabetes is peripheral neuropathy. And due to our domain knowledge, we can it seems that the results of our correlation analysis is true. Okay, so the peripheral neuropathy of the patient can contribute to the a difficulty of walking of the patients. Therefore, maybe the patient has a diabetes. So what is the implication of this one? So maybe patients with having difficulty with diabetes should be checked for the presence or absence of diabetes. Okay, so that you can treat the diabetic neuropathy if ever. Okay, then of course we are expected that high BP, as your BP is higher, you are also have the chance of having diabetes. Okay, because di ba, as we all know, diabetes is a being diabetic is a angina equivalent of, okay, of high BP. Okay, then of course heart disease, like that one. And we would take a look at the negative correlation. So as we can see here in our table, the most let me just so the most negatively correlated, so is the income. So we can interpret this as income has a moderate to strong negative relationship with diabetes mellitus. So what what would be the interpretation of this one? So we see again what's the income. Okay, for our income, this is the interpretation of our income. So it has 8 unique values from 1 to 8. So if it's 1 less than, then 8 is $75,000. So it means that as the scale goes high, the income goes high. So it's richer. So how can we interpret this one? So since it has a negative relationship, there is an inverse relationship or inversely proportional relationship. So meaning, okay, as the income of the patient goes higher, the chance of having diabetes is lower, and vice versa. If the income of the patient is lower, the higher the chance of the patient goes higher. So, 'di ba? It seems that it's true because in reality, no, if you have money to spend for your uh for proper food, like that one, or for having your check-up on doctors, like that one, 'di ba? Or your routine checkups, or buy medicines for diabetes. So the chance of your diabetes being controlled, or the chance of your diabetes being or developing diabetes would also lessen. Okay, and of course, if you don't have money to buy, like that one, so the chance of your diabetes would be you have higher chance of having diabetes complications because you have no money to buy medicines. Okay, or you don't buy healthy foods. Okay, you just eat sugar, like that one, or so the chance of diabetes also increases. Okay, so what what uh variable in our result is surprising. So it seems that it's okay, no? Positive relationship, age, okay, physical health, high cholesterol, okay. So I think smoker, if it's a smoker, weak, although it has a weak relationship because it's closer to zero, negative, it's closer, no, to negative, it's closer. So it has a weak negative correlation. So it means that as the patient smokes, or maybe as the smoking history of the patient, the years of smoking of the patient is lesser, the higher the chance of him having diabetes. Okay, why is that? No, so this seems to be a surprise, right? So you can analyze this one. So with other factors, okay. So it means that when you, am I right? So di ba, zero is non-smoker, one is smoker. So meaning the more you smoke, the lesser of you having diabetes. So this one is a surprising result. While syempre vegetables, right? So the lesser, 'di ba? It's okay. So the lesser you eat vegetables, the higher of chance of having diabetes. So in your recommendation, you should eat the vegetables because it can prevent you from having diabetes, because in your correlation analysis, no, it has a negative correlation analysis coefficient. So same is true with fruits. So you eat fruit so that you will not develop diabetes. Okay, education. So in here, what can we recommend? No, education, meaning what is the interpretation of the values of the education? Let me check again. Education. So education has 6 unique values. So one, never attended. So as you go higher, so the more educated the patient is. Okay? So it seems correct, right? So this means that it has a negative relationship. Means that as as the patient has a higher education, maybe is a college graduate, the lesser the chance of having diabetes. So we can therefore say, according to our analysis, that diabetes education is very important. Okay? So yan. So we can support that one, no? So that when we recommend, we can support by this evidence that education, as the education goes high, so as the patient is more educated about diabetes, about what to avoid, about how can he prevent diabetes, siyempre, the more he will not develop diabetes. Okay? Then the physical activity, again, so you should also always base on your the interpretation of your variables, the description of your variables. So physical activity, 0 if there is no physical activity and 1 if there is. So meaning, if you don't have physical activity within past 30 days, or if you have lesser activities in the past 30 days, your chance of having diabetes is higher. So therefore, we will recommend exercise. Okay, so that's how we can, what's this one? We can apply our correlation analysis. So I hope this correlation analysis is very clear to you. Okay, then as I have said a while ago, this correlation analysis is very important for our machine learning task later on. Okay. So, in our result, we can therefore say that we can include, okay? We can first, di ba, the best practice is we include all our date, all our variables that has positive correlation. Okay? And so how is that? Di ba? We have your data set. Di ba, in machine learning, you need to have your data set. So, those with zero correlation and negative correlation, you now delete during your data cleaning, so that you will only save your data set to be used for machine learning training and testing with these variables that has only positive correlation. Okay, so that's the first step. And then, so you train you, so you should have a separate data set. So maybe you copy all your data regarding this one and place it in another Google Sheet. Okay, then save it as a data set one for the machine learning to be trained on. Okay, and then try to, and then you do now your machine learning training and testing, and then after that one you evaluate. Okay, you evaluate you do your evaluation matrix, your accuracy, precision, like that one. And then, lucky for you, okay, lucky for you, if you have, if you include your if you include your correlated positive relationships already, okay, it's high already, okay, it's meaning you have accuracy rate maybe of at least 85%, okay, like that one, okay, you are lucky now, okay. But if you are not satisfied with the performance matrix of your machine learning, that's the time you do your feature engineering. Okay, feature engineering means that you further explore, okay, your data set. So one way is you can add another variable, or you can delete, or you can exclude other variables and see if the performance level of your machine will improve or not. Okay, so in our case, how? So maybe our second data set would include those with to uh, moderate to highly correlated values. So for example, in here, we can include maybe 0.3 to 0.6. So again, you copy the data of your general health. So this will only, so it's only 4. Okay, you have not only have 4 variables. Okay, now you save it, and then maybe you save it as a data set number 2, and then you run again. Okay, you run again in your ML, and you are happy that after running it, your accuracy improves, no? Your accuracy improves maybe 87%, 88%, like that one. But if your performance evaluation of your machine learning did not increase, and it 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 further decreased, okay, what does it mean? If your, di ba, after it, so if your machine learning after feature engineering improves, retain what you have if what you have done, no, the latest what you have done. In our case, we can consider that we only include the general health difficulty, high BP, heart disease. But if after machine learning and the performance goes down, syempre you will choose the prior one, the higher one. So in your machine learning and in your deployment, you should include this, the higher, diba? We want naman our machine learning uh, performance to be higher always. Okay, so that's the beauty. So feature selection by selecting only the positive correlated. Of course, you will not select the sex, why, or the stroke, or the smoker, or the veggies. Okay, because in machine learning, it's always prediction. It's always positive prediction. Okay? You will not predict based on negative values. You predict always from the positive values because it's always directly relationship, okay, in machine learning. So don't forget that. Okay? So first one, and then feature selection, then feature engineering. Okay? Then how can we further feature engineer this one? So for example, you included all of the positive. Okay, also uh, how can you also know what variables you will include in your machine learning in your data set, or in case of research, how can you interpret it? So this is where, okay, this is where our inferential statistics comes in. Okay, so we will go now to the inferential statistics, di ba? So our correlation matrix only shows us what is the relationship. Is there any relationship? Is it strong? Is it how strong the relationship. Okay, how is it positive, negative, or linear? But it does not tell us that it does not tell us if the relationship is significant or not, or if it is has bearing or not. For example, let's say we know that general health, as general health increases, as good health, as the more good health, the diabetes. Is this true? Like that one. So we need to prove that it is significant statistically. So that's where inferential statistics comes in. So are you getting my point? So it's not enough, no, to say that there is a relationship. The more important question is this true or is this significant? Okay, so that's where uh, uh, inferential statistics comes in. And this, you can use this as your feature engineering. Okay, so let's go now to the inferential statistics. So in inferential statistics, so what is inferential statistics? It allows us to make predictions or inferences about a population based on a sample of data taken from that population. So it is a test, no, used to determine whether this is a significant difference between the means of the two groups. Okay, so it is based on the means. Okay, so how can we do that? Okay, so let me just go back to our Google Sheet. Okay, so how can we do that? So for example, you want to wait, where's our correlation? This one. So for example, BMI and diabetes. So, di ba, we found out that there is a positive, although it's a weak to moderate positive correlation between BMI and diabetes, meaning as the BMI of the patient increases, as the patient becomes obese, the higher the chance of him or her being diabetes. Okay, so that's the premise. So is this true? So you ask yourself, is this true? How can you prove that? So you can prove that by asking if there is a significant relationship between the BMI and the diabetes. So how can we do that? So first, if it's a category, if it's a category, so what you will do is you go to your data set. So in here, so you go to your data set and again perform. So for example, in our data set, this one, so we perform again filtering. Okay, filtering data, create a filter. After creating a filter, what is our target variable? Our target variable is diabetes binary. So we will compare, since we are predicting 0, which has no diabetes, or 1, which has diabetes. So we would like to compare if the BMI of those with diabetes is statistically significant with those of the BMI with no diabetes. So therefore, we will compare these two groups with diabetes and no diabetes. So in order to do that, first, we will filter our data to show the one first with no diabetes. Then okay, so all. Then our target variable is our BMI. So you might want to copy all the values of the BMI of with no diabetes. So copy it. And then again, show it in another table. Then label this as with no diabetes. Then paste here. Okay. So you can format this one. Okay, you can format this one. Then go back to your data set. And this time, you get the BMI of all the patient of all the data that has diabetes or that has the value 1, and then okay, and then you go again to your BMI column and copy all the BMI again. So these are the BMI of those with diabetes. then go to your sheet and then label this one as with diabetes, and then copy here. Okay, and then you are ready to compare these two groups. Okay, so I hope you are following me. Okay, so one way, as I have said, is the t-test. So how can we perform t-test? So again, we go to the extensions and then the XL Miner analysis toolpack and click start and wait for the analysis toolpack to load in your right side of your Google Sheet view. And then here, okay, you can actually use t-test and ANOVA. Okay, it's same. So if you use t-test, t-test's analysis has different functions. So you can do t-test paired to sample for means or to sample assuming equal variances. So this one is for the mean, this one is for the variances, which is the data set. And as you can see, you have equal and unequal. So the next thing you will do here before you decide. So how can I decide, Doc, what to use? If it's equal or unequal. So you can decide it by getting if the number of data set or data points in or the number of BMI of with no DM is equal to the BMI of with DM, syempre you will use the equal. If it's not, of course you will use the unequal. Okay, so you should scroll down and then you, diba, it's you can see naman that it's unequal because okay, the last data point in one of your column is not same, okay, at in your other column. So in our case, the last data point in our patient with DM is at cell, it is at row 20, while our with no DMs at row 32. So there is an equal variance. So therefore we will use the unequal variance. So just click this one. So how can we input this one? So we have variable range 1, variable range 2. As I have said, t-test, you can only use t-test if you compare two variables. If you want to compare three groups, okay, like for example, if your category with no DM, with DM, and with pre-diabetes, so that's already three groups, you cannot analyze it using t-test. So what you will lose is the single factor ANOVA because in here, it only asking you the input range. So you can select the three input ranges, including if you have a pre-diabetes here. Okay, so I hope we are clear. So since there are two, actually we can also use ANOVA single factor. Okay, it's the same, or the value is also the same. So it depends on what you want to use. Okay, so for this lecture, we want to use the equal variances. Okay, so since it's in an equal, so you select that one. Then again, you select first, okay, your cell ranges before clicking the variable one range so that it will be copied here, or you can also type manually here. Okay, then your variable range 2, this one, and then click here. Okay, it's there. And then again, if you included the column header in your rows, in your cell ranges, you should click the label. Okay. Now, what is alpha 0.05 and alpha 0.01? What is alpha? So actually, alpha, it will tell you how confident or how sure you are in your, how sure you are that there is significant difference or there is no significant difference. If you use alpha 0.05, if you use alpha 0.05, that means that you are 95% sure that the BMI between no diabetes and with diabetes is significantly different, or in our case is significantly weak or strong, is significantly strongly positively correlated. Means that you are 95% sure that uh, I'm 95% sure that as the BMI of the patient goes high, the chance of the patient of having diabetes is also high. Okay, so like that. And if you use the 0.01, it means that it's higher, 99%. Okay, so it's 99%. So in medicine, the minimum, since our, di ba, in medicine, we are dealing with life and death like that one. So therefore, it's important that we are at least 95% sure. But the best practice is you should you should get, no, the confidence level, or the alpha at both 0.05 and 0.01, because sometimes, no, it is there is significant difference, no, when you use the alpha 0.05, meaning when you are 95% sure that your BMI, no, has significant relationship at 95%, but you are not 99% sure, no, that BMI has significant relationship. Okay, I hope you are getting my point. Okay, so like for example in real life, no, so if one said that you are 95%, I am 95% sure that he is good in mathematics, but I am not 99% sure that he's good in mathematics. So that's different things. So are you gonna believe the 95%, or are you more gonna believe the 99%? So depending on the case, if you are comfortable that in the 95% that he is good, so that maybe, so so be so you proceed, no, you proceed that 95%, no, that is good in mathematics like that one. Okay, so how can we again, so it's either 0.05 or 0.01. Okay, then again, so we first test it at the 0.05. So at 0.05, what is the output range? So again, let's see, we will place your output range here, and then we click the output range there. Okay, copied, then press OK. Okay, then wait for the data. Okay, so here is our t-tests. I hope you already see this one in some of the researches you have already read. Okay, so this is the t-test to sample. So this is the mean of the diabetes with no DM, with the DM. This is also the variance. The variance is the difference between your highest number and your lowest number. So in our case, no, yan. So observations, the number of observations. So it is clear that we have an equal number. Okay. So the one you will see here. So doc, how can I interpret it? Okay. So if you are using it as your table in your research, don't forget also to place here your alpha. So alpha equals 0.05. Because I have said it's either alpha 0.05, 0.01, 0.03, like that one, but usually 0.05 and 0.01. Okay. And then, so how can I interpret this one? So the important value here is your two-tail, while two-tail, because it has at least two values. Okay. So two-tail, what is the value of our two-tail? This is our p-value. Our p-value is, okay, is equal to 0.0849. Okay, now how can we interpret this? So it's very important. So we will step by step. So before that, we will first declare our null hypothesis. So we will declare your null hypothesis. So what is your null hypothesis? Meaning null hypothesis is the negative hypothesis. So what can we, di ba, we say that inferential statistics, we are sure that there is a significant difference. So therefore, our null hypothesis would be there is no significant difference, okay, between BMI and diabetes binary. Okay, so how can we interpret this one? So this is null hypothesis. How can we interpret this one? So first, compare your p-value and your alpha. If p-value is lesser than the alpha, so what do we do? Do we reject or do we reject? What do you call that one? Wait lang ah. Do we reject or do we accept the null hypothesis? Okay. Accept the null hypothesis. Okay. So, are you sure, ma'am? Accept the null hypothesis?
I reject. Kasi dun sa Excel, if it's less than 0.5, parang ganun ata yun sa Reno.
Oh,
Sa
yan.
Excel
Hindi ko.
kasi nasanay ko.
Excel. Okay. So, yeah. Excel. Hindi, same. It's the same whether you use Excel or not Excel. Okay? So, if the p-value is less than the alpha, we reject the null hypothesis. Okay, so we reject, So we reject the null hypothesis. Meaning, if we reject the null hypothesis, therefore, there is significant difference between BMI and diabetes binary. So, in our case, the p-value is 0.08 and the alpha is 0.05. Okay. So, what's the meaning of this? So, we reject or we reject. We accept or reject the null hypothesis. Nalilito nga. We accept the null hypothesis since the alpha is greater than the, tama? Let me
Yes,
check
sir.
lang.
So there is a significant difference.
There's a significant difference. Tama ba? Hindi, we accept We accept
Yes,
the
sir.
null hypothesis. We accept the null hypothesis.
We accept. So
The
ibig
P,
sabihin, there
there
is
is
a
no.
significance.
There is no. We accept the null. What is our null hypothesis? Wait, let me check.
Oo nga pala.
Yeah, the null
Nalito
hypothesis,
ako,
there is no
nalito ako.
significant. You always step by step. So you get your alpha, you get your p-value, and you state first your null hypothesis. Wait, let me just check. So, wait lang. Let me check. Let me double check. Okay. So if the p-value is less than the alpha level, okay, we reject the null hypothesis. So what is our null hypothesis? Our null hypothesis is there is no significant difference between, okay, BMI and diabetes mellitus. Therefore, okay, there is a significant difference. But if the p-value, wait, I will just write na lang here para hindi ka malito, ma'am. If the p-value is greater than the alpha, accept the null hypothesis. Meaning,
There is
there
no
is
significant.
there is no significant difference. So there is no meaning in your correlation between BMI
Yes, sir.
based on your data. Okay? So
Yes.
that's one. So since our p-value, which is 0.0849, is greater than the alpha at 0.05, so we accept the null hypothesis. So how do we interpret this one? Meaning, despite that we have learned that the relationship of BMI and diabetes mellitus in our correlation analysis is where is that one? BMI is weak,
Well,
'di ba? It seems that it's correct because 'di ba in our data it has only 0.1656, 'di ba? Meaning baliwala 'yan, 'di ba? So it has
yeah.
only a weak positive correlation relationship. So what does it mean? We can we are sure that in machine learning concept, in future engineering, so we are sure now that we do not get BMI to train our model because it will not give us meaningful result. Okay, it will not help us to predict whether the patient has diabetes or not. So I hope you are getting my point. So ganun po yun. That's the role of the t-test in machine learning. Okay? So
Yes, sir.
let us tests for the 0.09. Where is that? Oh, shit. Nawawala. Yan. So let us test if it's true with the 0.01 or the 99%. Okay, again, Excel miner, start. Then, again, to test sample unequal variance because it's unequal. So you select first, okay, then like that. Then select your second variable, like that. And then alpha is 0.01. Then you go now to the H, okay. Let me just, so that we can compare. Okay. Oh no, yeah. That's what I'm saying. There's an error. Input range contains non-numeric data because you included your label. So you click your label like that. Okay, this is the result. Okay. So they are still the same. Either, di ba? Oh, this one, no. So they are the same. Alpha. So zero
Yes,
point. So if you
almost the
are,
same.
yeah, if you are still in doubt, no, that is can I include BMI in my variable to predict like that one or not? So you test for the 99% so that you are 99% sure that you will not include that in your machine learning. Okay, so that's the value of having your t-test. Okay, so it's alpha 0.01. So 99% sure, no, that there is no significant difference because it's still the p-value is still greater than your alpha that it's 0.01. Okay, so let me show you if it's ANOVA. So so it's either ANOVA like that one. ANOVA single factor. Okay, let me check. Okay, again, this time when you use ANOVA, you only choose your ranges. Okay, then click this one and then label again first row, then alpha 0.5. So let us see. Okay, let us okay. So your alpha. Okay, what is your p-value? Okay, so still, diba? Yan, p-value. Okay, is 0.106. Okay. Alpha, so you label again, alpha equals 0.05. So still, diba, your p-value is greater than your alpha. So there is no significant relationship. And I think it's also the same. Let us complete this table. Okay. You can already, since it's the same, no? You can already just edit this one and your output range, which is T1. Click that one and okay. Yeah, let's see the p-value. Okay, the p-value is still the same. Okay, yan. Okay, so that's it. Okay, so that's how you interpret your, what's this one? That's how you interpret your p-value. Okay, so then, so we get another one, no? The negative. Okay, so your feature in your feature engineering, so you are 99% sure that you will now not include this BMI. So, okay. So we check for the general health. So is there a significant relationship? So let me just again. So this one is their general health. Take that one. So it's toxic, no? So you should know, no? What are those highly correlated that has a significant relationship? Because that's the variables that you will only include in your analysis. Okay, so let us, where is that one? Small row data. So let's, for the, what's this one? General health. Where's the general health? Let's test nga if, yeah. So again, we filter, then we go to your general health, then copy that one, then with no DM. Okay, then again, you filter, going to your, yan, okay, and then going to your general health again with DM, then paste your, where's that? Sorry, where is the general health? It's filtered already. The general health again, then copy, and then paste it. Okay, and then the next step, you determine whether it's equal or not. So it seems that it's equal. Okay, right? It's equal. Am I correct? Perfect. I'll just have to double check it. Okay. General health, diabetes. Let me just check it again. Where is the, general health. Yeah. Okay. Okay, so it's equal. So if it's equal, so let's first try the ANOVA. So if it's equal, so ANOVA, it doesn't consider the equality. Okay, so if it's ANOVA, again, let's select the input range, click that, and then let's first the 0.05. Okay, then the output range, then okay. Okay, what's the p-value? Okay, yan. The p-value is 0.000093. Okay, then, so what's the interpretation of this one? Alpha at 0.05. Okay, so what's our interpretation? Again, you can copy your p-value here when you're analyzing, but if you are now presenting your table, you just screenshot this ANOVA single factor until this alpha. Okay, so p-value is, you just copy here so that, oh no, p-value, okay, it's equal to, okay, so again, null hypothesis. Okay, so if you're a beginner, so that you can practice null hypothesis, so there is no significant difference between, what's this one, general health and diabetes binary. So what do we do? So what is the result? The result is,
There is significance.
kuan mo na ma'am, what is the result? Greater than or less than? So that you will not be
It
confused.
is
So
less
the
lesser than
p-value is, always start with the p-value ma'am. P-value is less
less than
than
the alpha.
the alpha. So meaning, we reject or we accept less than.
Less than
Le-
0.05 po.
Yeah. Do we reject or do we accept the null hypothesis?
Reject po.
Okay,
Kasi
so
mas
we
mababa yung P.
pag less than, reject. Pag more than, uh, accept the null hypothesis. So we reject the null hypothesis. So meaning, there
There is
is
there
a
is significance.
significant difference, okay, between yung, ano bang kaya natin dito?
General
General
health,
health and
diabetes.
diabetes binary. Okay, so you are 95% sure that you will already include this variable in your data set, in your machine learning. Okay, so I hope we are clear. So let's test it for the t-test na lang muna. For the t-test, so again, there is an equal. So you go to your equal, t-test equal variance. Okay. So for the t-test equal variance, again, you choose your first variable, then your second variable, and then click the label, and then 0.05. Then for the output range, let's place here. Okay, yeah. Then output range. Okay, then press OK. So let us see what's the, repeat. Again, the two tail is the P2 tail. So same lang. It is, same lang, di ba? So it's already the same. We have po
Yes, sir.
931874442. Okay, so yan. So the decision, no, the decision if you will use ANOVA or t-test depends on the number of groups that you are uh, that you are comparing. Okay, so it's still no 0.0009. So there is a significant difference. Okay, so yon. So yun lang po. That's all for our inferential statistics. So I hope it is clear now. In Python, you can have your this one. So basta you do your correlation matrix first, then you copy your variable, no? That's why it's in your data cleaning before your analysis, be sure because there are certain like the heart failure, like the heart failure data set, if you use that one, the dependent variable is at the end, is at the last column. So it's better that your dependent variable or the one that you are predicting is always at the first column or the A column, so that when you do uh, your correlation analysis, it is easier for you, no, to copy paste. Because because for example, if your dependent variable is income, okay, so you need to transpose again this one, so you need to use this one. So it's difficult, it's more difficult for you to manage your data. So be sure that always your dependent variable, no, in your machine learning, whether you're doing sentiment analysis that has category that is a positive, neutral, or negative, that one you can do ANOVA, since you are comparing three classes or three categories. So if you are comparing three or more classes, no, if your machine learning will compare, no, will predict three or more classes, always use the ANOVA, because you cannot use the t-test. But if it's only yes or no, good or bad, positive or negative, you can still use the t-test. Okay, but yan, you can use both naman. Okay, then 0.05 and 0.09. So if you're not sure, that, for example, di ba, our BMI in 95%, uh, uh, most of the researchers naman, you only do your 99% if your 95% has no significant relationship. As a no significant relationship. Okay? So if because some of the variables, no, they have as the percentage of alpha increases, no, the significant relationship also the relationship also becomes more significant. So you can perform your alpha at 99% or both. So you can compare. Okay? So yun, you can compare deep walk, heart disease, like that one. Then whoever variables here that has the significant relationship, okay, you try to save it again in another data set. Then you look if the data set if your machine learning algorithm, or if your machine learning model improves in all the accuracy, like that one. Okay? And then, so because, di ba, in machine learning, when you predict things like this one, so you will do up. So, you up. So, your user app what is your general health? Like that's one. And the choices is 1, 2, 3, like that one. So the user selects 1, 2, 3, and then diff walk. Oh. Do you have difficulty with walking? Like that one. 1, 0, or 1, like that one. Or heart disease, 0 or 1, like that one. So in your app, like that one. So in your app, what is general? So the patient may be 1, 2, 3, like that one. And in the end, there's a button there give me prediction, or give me the prediction rate of having diabetes, and ganyan. So for example, yan. Then when you click the button, your machine learning algorithm will run, and then it will give you prediction rate. Usually prediction rates, no? I hope you see now. Maybe your machine learning model will give you a 19% you will have diabetes mellitus, like that one. Okay? So that's the beauty of your machine learning and your algorithms. Okay? So this one kasi it has no age. So, done. So you always deploy your machine learning with the highest performance matrix. Again, you will learn, I hope you will learn from your next subjects, no? When do you use accuracy, precision, F-score? But in reality, it's still based on your use case and if there are previous researches. Like me, the prediction of the ICD code, so I search, no, for related literature. What is the acceptable benchmark? So your benchmark. So I hope you are familiar with your benchmarks. Okay. So that's for our inferential statistics. So you are now ready to train your model. Okay. So now I just want to show you a special that you can use, no, in your researches. Most specifically, if your researches, no, the interpretation of your research would require you a weighted mean of questionnaires. So like for my research, no, that my study, no, that I assessed what are the factors that affects the end user acceptance of our hospital information system, no, using questionnaire. So this is the one of the research question, no, to determine the level of acceptance in terms of these factors. So perceived usefulness, compatibility, self-efficacy, like that, and so on and so forth until his acceptance. So my questionnaire, no, is a 44 item questionnaire. So each factor, each of the 12 factors, no, has its own item questionnaires. Okay? Then how can you interpret that one? So, di ba, my questionnaire has a Likert scale. If you are familiar with Likert scale, like 1, very low, 2, 3, 4, 5, and the user response if it's 1, 2, like that, and there's a corresponding label, like 1 is very good, 2 is good, like that one. So if your questionnaire, no, if the interpretation of your questionnaire would require you to get the weighted mean, how can you get the weighted mean from your data set, no, that I will show you by and by. Okay, so this one, like this one. So for the his acceptance to be desirable, the weighted mean score of the questionnaire of that person should be more than 3.75. Relatively desirable if it is has that score, and if it's undesirable if that's less than 1.5. So uh so this is the sample of my questionnaire so that you can have idea. So for the first factor, it's for the number 1 to number 6 question. So this is my questionnaire. So this is the Likert scale that I was telling you. So for 5, very high, 4, high, yeah, like that one. So there is a 5, 4, 3, 2, 1. So the respondent will just check, okay, each item, what is the using his would examine my effectiveness in my job. So he will check if very high. So if he believes that if he believes, no, if he believes, if he accepts these statements that the newly implemented his enhance his job, he can check 5, okay, like that one. So how can you, diba, for example, you use Google Sheet with this format and you exported it using your Google Sheet. So I will just share my Google Sheet. Okay. So this is the Google Sheet. So I imported, no? I import. So this is, diba, in our Google Sheet. In our Google form, you can export. You can use your Google form now as your questionnaire. Okay. Then you just link it to a Google Sheet or a Google, or just export it in a Google Sheet or save it in a Google Sheet. Then this will be okay. This will be the appearance, no, how the Google form exports its data in Google Sheet. So this is the question number 1 again. So the as I have said, the questions, no, will be will become the column headers of your will become the column headers or your variables. Okay, this will become your variable. So for example, you ask what is the age of your patient, so this one will become the age of your, what is the, so if you're here in data cleaning, okay, part of your data cleaning would be changing your uh column header name into its proper name, meaning, for example, into its shortest possible name, so that, for example, this one, using his would enhance my effectiveness in my job. So it's very long, okay? So you can, because if you adjust this one, so you will no longer, your view will become very difficult because you need to scroll from here to there. So that's one, age, sex, like that one. Then highest educational attainment, you can use attainment, like that one, so that it's shorter. Okay, so so this is the exported data of my questionnaire. So it's the real-time questionnaire. So first, no, before analyzing again, convert all, okay, convert all data into its numerical value. So as you can see, this one is okay because it's in numerical values. How about age, sex? It's you gather your questionnaire, no, in this one, 45 to 50 years old. So you can do what we called one-hot coding, meaning you can designate, for example, you can designate letter A into 0, uh, B into 1, like that one. So you can use the formula ifs, okay? So I hope you know now how to use the formula ifs, okay? So like that one. So since I am showing you how to get the weighted mean, okay? So how can we get the weighted mean? So first, so for example, this one, okay? So the perceived usefulness factors, no, reflects this questionnaires, this one, 2, 3, 4. So the first 4 questionnaires would assess the perceived usefulness of the user. So it depends on your use case, okay? So how can we get our weighted mean? You cannot simply, 'di ba? Column A, you cannot simply get the mean. 'Di ba? You cannot simply get the equals, 'di ba? Mean like that. No, sorry. Average. You cannot simply do that. Okay, that's not the weighted mean. Okay, so you can see, where is that one? Okay, so 4.07. You cannot do that because it's different. Okay, so what you will do is to get your weighted mean. For example, we will get the weighted mean of this column A, of this one, column A. So first, no, we get columns for 5, 4, 3, 2, 1. So we get the number of respondents in our column A, which is this question. How many of them answered 5? Okay. So the formula is count if row data A4 to A. Okay, count if this row is 5. This one. So the value is 34. And so on and so forth. So count if row data 4, count if row data is 3, count if row data is 2, count if row data is 1. Okay, so meaning in my item number 1, 34 answered 5, 39 answered 4, 27 answered 3, none answered 2, none answered 1. Okay. Then what is this? So you add, so after each scale, Likert scale, you add another column between them. So what is this one? So you multiply the number of respondents that replied to the Likert scale times the Likert scale itself. So the formula here is B3, which is 34, times 5. So you get 170. And also this one, this one, this one, and this one. Okay, and then you total the respondents and you total the score. So this is the score. Okay, score, 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 score. Okay, then you get uh, the total respondents. Okay, so the 100 will be the total of this one, this one, this one, this one, and this one. And the total score would be this one, this one, this one, this one, and this one. So then how would you get the mean? So we simply divide the total score divided by the total number of respondents. So this one. So we have a total weighted mean score of 4.07. So if we go back to our uh, interpretation, 4.075, this one, so 4.07, So, meaning, uh, my respondents have, they accept, no? They have they accepted, no, that the newly implemented HIS has enhanced their effectiveness in their job. Okay? And if it's less than 5, it means that they did not enhance their effectiveness in their jobs. Yeah. Then that one, you can analyze your research questions by item, like that one. And if you would like, you can get their mean by mean average na, so that you can get this average. Then the standard deviation again. This is the manual, no? Standard deviation, okay? Standard P for the population, standard S for the sample. Okay? So that one. So overall, in terms of perceived usefulness, 4.05. So meaning the users perceive the newly implemented hospital information system to be desirable. Okay, so that's the result. Okay, so that's how you get your mean. Okay, so I included this because, so, syempre, when we do research, no, we will encounter this one. Depending on your research. If your research questionnaire or your tool uh, wanted wanted you to get the weighted mean so that you can interpret the result, so this will be the way. The other tools like the system usability scale that assess the usability of certain application, no, it has also a way of interpreting, like there's a formula. Okay, so depends. Okay, so that's it, no. So I hope you can. Then for visualizations, okay, histogram, scatter plot, so just a little bit, no. So we go now to your data visualization. So in data visualizations, I want you to learn four, no, when do you use, no, histogram, when do you use scatter plots. Okay, histogram, continuous variable yan. Then you can read this one, scatter plot. You can only use scatter plot when you are comparing two continuous variables, no. You cannot compare, like for example, female as 0, male as 1, and then you compare it to the age. You cannot compare that using scatter plot. You can compare, for example, whether as the BMI increases, will the as the age increases, will the BMI increases? So yan. You can see, no, in the scatter plot, if there is a positive directly correlation or negative correlation. Line graph, bar graph. So I hope you are already familiar this one. So uh, uh, ayan. So you can do your graphs. Where's the graph here? So histogram, column chart. So I hope you are now familiar. So with the column chart. So in the bell curve, there is a formula, no, in the bell curve in the Google Sheet. I don't know yet if it's applicable in the Excel. So to be able to show this bell curve, no, you can get your mean, standard deviation, SD negative, standard deviation -3, standard deviation negative +3. So there is a formula. So you just copy the formulas, no? Then you get your sequence. So this is the formula, then its distribution. Okay, then you plot this one. You plot this one. Okay, you plot this. Okay, and insert it as line chart. So chart, it's a line chart actually. Oh no, it's a line chart. So it's a line chart. Where's my line chart? Yeah. Okay. You can use that as label. So you can do that, or you can, okay? So that's how you can. Then if cross tables, in cross tables, di ba I have already discussed the pivot tables. So if you, di ba, if you are having your research, then you are getting your demographic profile. So you can use the what's this one? The cross table. So your independent variable goes here, and your diabetes and your dependent variable goes here. So that it's one view already. You don't need to get a table separate for age for diabetes, or age for non-diabetes, and age for diabetes, because it already give you the grand totals. You can interpret it as, for example, this is your table one. You can interpret this as overall, the age of our patients in the data set, no, is 976. No, that belongs to age group one is 979, like that one. Then specifically, among those with diabetes, it's 901, like that one. Uh, so that you will only have a single table. Okay? So what else? I hope you are now masters naman na with your charts. Okay? You can do your bar chart, column chart. Okay, the bar chart, what is bar? This is a column chart, right? The bar chart is that one, that one. So bar chart, you can use your bar chart when you are showing rankings. Like you want to filter what's the highest to the lowest, like that one, because it's easier to for your audience, no, to see, no, that the ranking. Okay, this one naman, it's for the trends, as well as the line graph. It's for the trends, and also for the class imbalance. Okay, you will be able to see the class imbalances, no, using column charts. No, for example, here the age, no, is there a class imbalance? Yes, it seems that there is class imbalance because others have 10,856, 979 only, like that. Okay? Okay, so I think that's all for our Google Sheets. No? I will upload this video again. Then I will upload an activity po. Di ba you have now your what's this one? Your midterm exam. Uh, you are done, ma'am, in
Sir, ano po
your
lang ako, meron ako yung data clean po, tsaka yung 10, yung step 10 po, hindi pa tapos.
okay, ano nga ba yung step 10, yung ano, hanggang sa kwan lang naman tayo, di ba, ma'am, sa our midterm is only up to the, saan nga ba yung sinabi natin? Up to the, I think we are only up to the uh, pivot table, right? Then you include your interpretation. So up to the frequency tables only. When you did your specific objectives, we are only up to to determine the profile in terms of like that one, diba, ma'am? Then so that you can practice this one, ma'am. Okay, I will upload again an activity. Okay, siguro your midterm and your one is you can submit it, ma'am. Yeah, you can submit it before the semester ends. When will your semester ends? I think it's October, sorry, August
August,
12.
second week, sir. Yes, second
Second
week
week of
po.
October. So by
Isa po.
that time, okay, you can so that ma'am ma'am Janelli might ask your exams. But before, di ba, in your other
Po.
subjects ba, you are allowed to submit you are allowed to complete all your requirements, di ba?
Isa po.
Before
Before the finals.
Finals? Okay.
Opo.
Including your midterms, right?
Opo.
Okay, so sige. August 12 siguro lahat, ma'am. August 12. So we have one activity and your finals would be on WECA.
Weka na po. O sige po,
Yeah,
mag-advance ako sa
yeah,
Weka.
WECA.
So, no more Python,
WECA.
sir.
No more. In ko na lang. If I will still be your teacher next sem in
So,
our
yun na
machine learning
Python.
proper. Kasi Python
Sige
will
po.
be bitin.
Kaya nga, sir.
Weka, you need to then you need to know how Weka works. For me, no,
Okay.
I also having difficulty in using Weka before because in Weka it depends on your data set. This data set, this diabetes data set that consists of 10,000 plus, Weka is having difficulty of processing it.
Really? So, mas
Yeah,
maganda po ang Python.
yeah, because in data set in your Weka, you will there is still a visualization. Then you can now perform your precision, accuracy like that one. So I will I will find time tomorrow siguro to record, or if not I will Ma'am generally has a recording about Weka. Or maybe we can use that if I ask permission from her, or I can just record you in the lecture, and then we can that's August 5. We can I know August 5 I will not be here in August 5. We are now we will can discuss Weka on August 12. Okay.
Sige po.
Okay.
Or na-i-upload mo na lang, sir, tapos panoorin na lang din namin.
Yeah. So that you can connect. So and then I will give you now in advance your exam in Weka. So screenshot naman.
Sige po.
Okay. Sige, ma'am.
Okay
You
po.
don't have ma'am.
Thank you po, sir.
You don't have any schedule at 12 like that.
Well,
Duty.
night as much, sir. Okay lang.
Okay.
Night, okay.
Sige.
Basta Sabado lang, sir. Okay naman ako.
Okay. Sige, ma'am.
Sige po.
Okay. Your other subjects, Sabado din?
Hindi po. Miyerkules po kay Ma'am Janelli.
Sa research, ano?
Abo, sa research po.
Oh, okay.
Opo.
Sige.
Opo.
Okay, ma'am. Sige. Okay, ma'am. Sige. See you on August 12. Message na lang ako sa group, ma'am. Okay. Sige, ma'am.
Okay.
Thank
Opo.
you. Okay.
Thank you, sir. Salamat po.
Mm-mm.
Opo.